In this video, I want to talk about the difference between differentiability and continuity and how they relate to each other. Well, differentiability, first of all, means that you can differentiate function at the point. It means you can find the slope of tangent line at the point. That's the differentiability. Now continuity, on the other hand, means the function is continuous at the point. It means the function does not have gaps, breaks, or jumps at x equals c. This is continuous if that's x equals c. This is not continuous because you're having a jump at x equals c. This is also not continuous because you have a vertical asymptote at x equals c. F of c is not defined, and you can think of other cases. That's going to be another one. If it's going like this, that's not going to be continuous. Now, how do differentiability and continuity relate? Well, for something to be differentiable, let's say you have this function. Let's say you have a function that's going like this and like this. And they're asking you to find the slope at x equals c. How would you be able to do that? Well, how can you even draw the tangent line in this case? Well, that doesn't really seem to cut the case. That doesn't seem to cut the case either, because that's our point, and it's not connected. The graph is not connected at x equals c. So it doesn't make sense for something to be differentiable. You cannot really draw a tangent line at x equals c if the function is not continuous at x equals c. So if for differentiability to work, the function has to be continuous. For differentiability to occur at x equals c, the function has to be continuous at x equals c. Differentiability implies continuity. Now, does continuity implies differentiability? What I mean is that if something is connected, doesn't mean we can find the slope of tangent line. Well, how you can think about it? Think of absolute value graph, the one that's going like this. What's going to be the slope at x equals c at this point? Well, the slope from the left, the tangent line from the left is this, tangent line from the right is this. So since the slopes of these tangent lines are not the same, you don't know how to draw the tangent line at our point x equals c. So this is not differentiable, even though it is continuous. So continuity does not mean that it has to be differentiable. You can think of another case. If the function is going like this at x equals c, you see the tangent line is going to have undefined slope. It's going to be vertical, so the slope is going to be undefined. And in this case, it's continuous and it's not differentiable. So the continuity does not necessarily imply differentiability. Does not have to imply differentiability. If something is differentiable, for something to be differentiable, it has to be continuous. If something is continuous, it does not have to be differentiable.